My name is Marjorie Cabilogan.
And I am Abigail Javier.
And we are your tutors for today.
Today we're diving into a statistical tool that holds an importance in hypothesis testing, the z-test.
Our goal is to understand this statistical method and how it plays an important role in hypothesis testing.
And also to evaluate whether the finding is important, significant, or not.
And now, before we dive into the z-test, let's set the stage by exploring the broader concept of hypothesis testing.
Hypothesis testing is a form of procedure for investigating our ideas about the world using statistics. This allows researchers to determine whether the evidence supports their claims, hypotheses, helping them to avoid false accusations, claims, and conclusions.
Hypothesis testing also provides a framework for decision-making based on data rather than personal opinions or biases. By relying on a statistical analysis, hypothesis testing helps to reduce effect of chance and confounding variables, providing a robust framework for making informed conclusions.
A z-test is a type of hypothesis test, a way for you to figure out if the results from a test are valid or repeatable. For example, if someone said that they had found a new drug that cures cancer, you will want to make sure it was probably true, right? A z-test or hypothesis test will tell you if it's a probably true or probably not true. A z-test test will tell you that your data is approximately distributed or normally distributed, like this graph.
The data has the shape of a bell curve when you graph it.
A z-test is conducted on a population that follows a normal distribution with independent data points and has a sample size that is greater or equal to 3. It is used to check whether the means of two populations are equal to each other when the population variance is known. The null hypothesis is a z-test that can be rejected if the z-test statistic is statistically significant when compared with the critical value.
You would use a z-test if, first, your sample size is greater than 30. Second, your data points should be independent from each other. In other words, one data point isn't related or doesn't affect another data point. Third, your data should be normally distributed. Fourth, your data should be randomly selected from a population where each item has an equal chance of being selected. And fifth, sample sizes should be equal in all possible cases.
The z-score is a statistical measure that determines how far a data point deviates from the mean. It is calculated by subtracting the mean from this data point and dividing the difference by the standard deviation. The standardized score helps in understanding the relative position of a value within a dataset and is commonly used in statistical analysis and hypothesis testing.
The value of the z-score tells you how many standard deviation you are away from the mean. The positive z-score indicates the raw score is higher than the mean average. For example, if the z-score is equal to +1, it is one standard deviation above the mean.
A negative z-score means that the raw score of the mean average is below the mean. This is the mean. For example, if you have a z-score of -2, that means you are 2 standard deviation below from the mean. Another way of creating or interpreting the standard normal distribution or the z-test standard normal distribution is through graphing this. For our first sample question, for the first half of our solution, first we're going to construct a hypothesis. So first we're going to identify what is the null hypothesis and then the alternative hypothesis. So for the claim, we're going to identify the alternative hypothesis through our claim, which is the greater than 40,000. So we can use this or even write the sign as greater than 40,000 and use it as our alternative hypothesis, which means we can write this here like this. $40,000. And the null hypothesis, which means the inverse hypothesis of this alternative, which means
Less than or equal to
40,000. Now we have identified our hypothesis. For our first solution to our problem number 1, first we're going to construct the hypothesis. The hypothesis or the null hypothesis and the alternative hypothesis. So where did I get this one? First, the alternative hypothesis is the claim or the researchers that claiming that the average salary of the private school teacher is greater than 40,000, and we're going to prove that or not. Okay, for the first is the alternative hypothesis is greater than 40,000. So the null hypothesis is the inverse or the opposite of the alternative hypothesis, which means it says here that it's less than or equal to 40,000. So after constructing the hypothesis, we're going to list down all the given and we're going to identify which test are we going to use. Is it the z-test or the t-test? First is the sample mean. Sample mean is the 42,000. For our population mean is the 40,000. Our sample size, which is the 35 teachers. And for our standard deviation, which is 7,500. And for our significance level or the alpha level is 0.05%. After identifying this, we can now put this in our formula, which is the z-test equation. For our substitute solution is, we're going to substitute the given data that is in here, and we're going to use our z-test equation. Z equals to sample mean minus the population mean over sigma, our standard deviation divided by the square root of sample size. Okay, first is we're going to substitute the sample mean, which is the 42,000 here, and 40,000 for the population mean, divided by our over sigma of our standard deviation, the 7,500, divided by the square root of 35, which is the sample size. And for our alpha level, or the level of significance, we're going to graph. Okay. Using that, here is the section or the region of rejected region, which means here is the 5 or 0.05%, and here is the 95%. And bakit ko ba nilagay yung part na dito, nasa right, imbes na dito? Because the word here is greater than, which means all greater than, or the level of increase or anything that is going upward or that it increase in amount is going to be written down in the left or the right side rather. And for the less than or anything that is less than equal is should be written here on the left side. So we're going to find our critical value, which will be presented here to you, our z table, where we can find the critical value of the 0.05. So we have found out our critical value, which is 1.645. And now we're going to solve our equation after substituting every data that have been gathered a while ago. So the answer for this using your calculator is equals to 1.8. And now we're going to find here, where do we place 1.8? Because 1.645 is from here, and then which means 1.58 will be placed upon here. So 1.58. That means our null hypothesis becoming true, or the claim in our null hypothesis is true, because part here is this place or this region is what we call the FER, or that failed to be rejected region, which means it is accepted. And
that leads to our conclusion that our null hypothesis will be accepted and our alternative hypothesis will be rejected. Because 1.58 is less than 1.645, which is our critical value and the z value. Okay. That leads us to our decision, which is our decision. That leads to our decision that the researcher's claim is false. Okay? So now we have answered our first problem. Now we'll let you answer this question for us to be able to know that you have understand our lesson.
You can pause this video for 5 minutes and answer this practice question.
First, we're going to identify what is the claim. The claim here that the principal is claiming that his student in his school are above average intelligence. So we can construct our hypothesis as first, our alternative hypothesis is, because this is the claim, that means it's greater than 100. Kasi it's above. The word above here speaks the greater than sign. And our null hypothesis is equal. The mean or the population mean is equal to 100. So our step 2, which is defining our givens and listing down them. Step 2 is our alpha level here it's constant that alpha level, if it's not stated, it will be a 0.05% or 5%. So we're going to graph it here. And so because it is greater than, the word greater than, we're going to write it in on the right side. And we're going to put this here, 5% here, and 95% because the overall graph is 100%. So this part means a rejected region. And this part is the FTR, or failed to reject region. And first, we're going to identify our z-score using our table. One day lang tayo, so dito tayo magre-refer. 5%, we're going to find the 0.05%. And dahil itong part na to is for t-table, then we're going to below, ayan, kasi z-table lang tayo. Z-table yung minutuan natin. 0.05, that means, ayan, 1.645. Ayan, after finding it, 1.645. Here, 1.645. That's our z-score. Okay, we're going to find our z value, which is, we're going to substitute our given to our z-test equation. So z-test equation formula is sample mean minus our population mean over sigma, our standard deviation divided by square root of sample size. So, substitute natin. Ano ba yung sample mean natin? Our sample mean is the 112.5. 112.5 minus our population mean, which is the 100, over sigma, our standard deviation, which is stated here at 15, and divided by the square root of 30.
For our third step, which is substituting the other data here in our equation. For our sample mean is the 112.5 minus our 100, the population mean, over sigma, our standard deviation, which is here, the 15, divided by the square root of our sample size, which is 30 here. And so the answer will be 4.56 using our calculator. So now we're going to identify which region are we going to put in the 4.56. So if our z or the critical value is around here, a 1.645, that means our z value will be put here around dito banda, somewhere here, 4.56. 4.56. Ayan, 4.56. That means our z value 4. Ayan, hindi siya ganun visible. 4.56 is greater than our 1.645. That means our decision will be for our step 4, the decision. Reject the null hypothesis. Reject the null hypothesis. And accept the alternative hypothesis. That leads us to a conclusion of the principal's claim Going back to the question, the principal claims that the student is in his school are above average intelligence. That will be our conclusion. So I hope you get it right on your part also. So that will be the end of our sample question for one tail.
So the second example is all about the two-tail. So since it is further explained on the last video, so here we have the sample. So the first step is we have to state the null hypothesis and the alternative hypothesis. So we have here the null hypothesis, which is the mean of 100. So our mean is equal to 100. And the claim here is a researcher thinks that a high diet and low cornstarch will have a positive or negative effect on the blood glucose level. So here we have an alternative hypothesis. So the mean is not equal to 100 because we don't know if it is greater or it is much smaller. The step 2 is state the alpha level. Since it is not mentioned in the problem, so we have to use the standard, which is 0.05 or the 5%. So here we have to divide the graph into 2. So it's supposed to be 2.5 and the left side is 2.5. But we have to make this negative because it is on the left side. So this is the negative part, the negative region and the positive region. So here, since it is divided, so the whole paragraph is in 100%, right? So since divided siya, so magiging 50% and 50%. Negative, I always use negative because nasa left side siya. Now we're going to find the critical value. Since it is given, the 50 and the 2.5, so we have to subtract this one to find the critical value. So here, 50 minus 25 is 47.5. Since we already have the z-score, we're going to navigate and find the critical value. So how are we going to find the critical value? So before we dive into the table, since we already have this z-score, we have to move this z-score into 2 decimal places to find the critical value. So it's going to be 0.475. And we're going to flash to the table.
Now, by finding our critical value, we'll use the table and look for our decimal point. So, as can you see here, it is 0.75 under the row 1.9. So, it is also under the column 0.6 on the upper part. So, let's go to the upper part. So, now our critical value would be 1.6.
So, step 3. So, dito yung calculate natin. Paano natin gagawin yung equation. So, malalaman natin kung nakukuha din pa sa dito or doon sa positive region. So, here we have the given. So, mean is 100. And our standard deviation is 15. And the next one is our sample mean 30. And the population mean is 100. So now, the formula is C is equals to the mean minus the population mean over the standard deviation divided by the square root of the sample. So now, ano na natin siya. So yung x natin is 140 minus yung sa population mean 100 over yung standard deviation is 15 divided by the square root of 30. And if you calculate this all, we have 14.6. And this is our z value. And now, makikita natin kung saan ba siya nag-ano, sa region band ng left side or right side. So now we have our z value, and let's compare this to our critical value, which is 1.96. So 14.6, 1.96. So what do you think? Saan region siya? So supposedly, dito siya sa region ng ito. 14.6. Positive. Malayo siya sa mean. So, to sum it all out, it is rejected. The step 4 is the decision. So here, since we already know where this 14.6 fall in, so we have to reject the null hypothesis and accept the alternative hypothesis. And the last step is step 5, which is the conclusion. So here, based on the problem given, we have to conclude that the blood glucose level of a obese patient have positive effect on the blood glucose level. So enable for us to know if you really understand our lesson, so we will give you practice questions or sample questions for you to answer, and we will give you 5 minutes for that.
You can pause it again for 5 minutes to answer this practice question.
Our two-tailed practice question. So first, we're going to identify the claim. The claim here is they did not spend 150,000. So we can write it here as not equal to 150,000. So our claim will be written as alternative hypothesis, and it's inversely to our null hypothesis. Our null hypothesis is equal to 150,000. And our alternative hypothesis should be not equal to 150,000. Okay, that's our claim, the alternative hypothesis. So our step 1, yes, we have done it. Our hypothesis constructing. Step 2 should be determining what is the alpha level or the significance level, which is stated in here that it's 0.05 level of significance. And the test will be using, because it is 48 resident, that means it's above 30 or greater than 30, it will be using a z-test. And the alternative hypothesis is not equal, that means we're going to use a two-tailed here. Okay, so here in a part, left-tailed and right-tailed, and here is the mean. So first, we're going to identify our critical value, the z-value, and first, before going to that, is to identify our givens. Okay, given, rather. So our sample size is n is equals to 48, and our population mean is equal to 150,000, and our sample mean is equal to 155,000, while our standard deviation is equal to 9,000. So now we have identified our given, and we're going to substitute it to our z-test equation, which is the z equals to sample mean minus our population mean over sigma our standard deviation divided by square root of n. And then, yes, let's substitute our given. 155,000 minus 150,000 over sigma our standard deviation 900,000 divided by square root of 48. And that will leave us with 4.23. 4.23. And before I forgot that we're going to find our z-score. Z-score, that means it says here that the 0.05 level of significance is 5%. That means this one is 5%. But they are two-tailed. That means we're going to divide it by 2. That means that will be 2.5. So, ayan, 2.5, both sides to. 2.5, and we're going to find the critical value, which is in our table. So, two-tailed. So, our value here is two-tailed tayo titingin. That means here, 2 and 5. Bale, around 1.960. 1.960. So, our Z critical value is 1.960, which is both sides are 1.960. So, our Z critical value is, here is, bale, both sides sila is 1.9. So this one is a positive, while this one negative. Negative 1.960. Kasi nasa left side siya and should be written as negative 1.960. So after finding the critical value of Z table, that means the positive and negative 1.960. Our step 3 is we have done it. We have find our Z value naman, which is the 4.23. So now we're going to decide for the step 4 is decision. Our decision will be reject the null hypothesis, which is the reject the null hypothesis here, and accept the alternative hypothesis because alternative hypothesis because is the mean or the population mean is not equal to 150,000. That proves right our alternative is accepted because the 4.23 or our Z value napunta siya sa right side, which is on the rejection part, and our Z score is 1.60. That leads to us sa conclusion hindi siya napunta sa FTR region natin, which is failed to reject region. That leads us to our hypothesis to being accepted and our null hypothesis being rejected. Okay? Our null hypothesis is rejected. Our alternative hypothesis is accepted. That leads us to a conclusion. Okay, let's go back to the question. A suburban community claims that their resident did not spend 150,000. So, did not spend a 150,000 on their housing. So, I hope that you get the answer also at our two-tailed sample question.
As we conclude, remember that the world of statistics offers a variety of tools tailored to specific situations.
And being familiar with this specialized test equips you to make an informed decision in your data analysis journey.
Keep exploring,
Keep learning,
and most importantly,
keep asking questions.
and again, I am Teach Mars.
And I am Teach Abby.
Thanks for joining today's tutorial.